welcome back everybody. This is the intermediate second weekend of the Android application development class, and I've uploaded a lot of new stuff between this session and the last session we had about a month ago, and then our last session is going to be in about 2 weeks. It's going to be April 13th, 14th. So we're going to fly through a lot of examples this weekend, and all of the examples, as I was mentioning before, just to refresh your memory where to find these things, because what ends up happening is I start going over something and then you start looking, where is this? So if you go into the Android Spring 2013 Android Phone Application Development link, which is the last one on the bottom, if you come up over here, I put in tutorials here. We also have, and in the tutorials down here, we've got the lower part from about tic-tac-toe downward. We've covered everything above tic-tac-toe except for the life cycle and the logging, which is what we're going to do in a few minutes. Everything is from tic-tac-toe downward. I actually put together, because we were talking about tic-tac-toe last time, and people were curious, how do you make the tic-tac-toe game with the buttons and stuff? So I actually put together, it took me about 5 minutes. I just kind of threw it together from what we were working on last time. At the end, on Sunday, if you guys were here, we were playing around with building a tic-tac-toe thing. So I finished it, put it together, and I stuck it out here. It is a tic-tac-toe solution 2. And I'll go through that one to show it to you. But we'll ease in a little bit with a little bit of a minor review in the beginning and kind of ease our way in, because I haven't seen you guys in about a month. So I don't know who's been thinking about Android between now and the last time I saw you. But this is the game plan. And we also have some other materials that I've put together in the lecture section here where it says lecture notes. So there will also be some lecture, every other kind of thing with some supplemental notes and some lecture stuff. We have here actually map projects and examples. This might help you with that mapping question that you had. Did you see this one? It's probably based on the old mapping API though. So I had a couple, one student asked about mapping stuff, which is, I forgot that was in there. But I believe that's going to be outdated. I need to give you a newer one. Probably won't do mapping until April 13th is what I'm thinking. But in the meantime, we have a lot of other things to cover this weekend. So this is where the notes are going to be as well. I've actually updated this since the last time you were here as well. So you'll find a lot of new stuff in here, is what I'm saying. So go through. And what I'm going to start out with initially is this one here. These are PDF files, AP Lecture 1. Which is going to be the kind of a little bit of a review for right now, which is this guy here. This is AP Lecture 1. It's a PDF file, actually. So onward. So let's get us back thinking about Android, because I know some people are in the iOS class and they've been thinking about iOS for a while. So we're going back to Android. And I just kind of want to review a few concepts just to get us all on the same page. And plus, it's kind of hard to pick up exactly where we left off, because then people are going, what? So... And then I'm going to kind of mix it up a little bit. We've been going through the application framework. Last time we actually looked at, today we'll look at notifications, a little bit on the location management. Really what we're going to be looking at is more activities, more window managers, content providers, and resource managers as a concept. And then some of the telephony stuff. But really what we're looking at is this framework here, and the applications that are built on top of the framework are the ones that we're creating that work with the contacts, the phones, the browsers, and all those sorts of fun things. We will also look at databases today, and we will look at SQLite and how to connect to a database, and how to use files with Android projects, and how to use data. We actually looked at the WebKit already, but we have another tutorial that we'll go over that will emphasize a little bit more on that. We also look at the graphics system as well today. Not do too much not really OpenGL, but we'll look at the graphic packages and compare it with Swing. If you're in the Java course, that's a nice little kind of comparison to it. So it's really the game plan for this weekend is to pick up a lot of the functionality. One of the features, going through many examples after examples. So just to refresh your memory, we have the app lifecycle. In fact, this is going to be the first. This is going to be the first tutorial we're going to go through because we left it out. This is the one we should have covered last time, actually, which was the app lifecycle. We also go through the information sharing and the logging kind of concepts. But in terms of information sharing, that's where we're getting our content providers from. And so the content providers are allowing us to share. And then we have the information presentation from the view system. We'll create a custom, we did a custom view actually last time, I believe. We'll be doing another couple of custom views this weekend as well. And then accessing location information, which is also kind of an interesting concept as well. That has changed recently within the last year or so. So we're now on a different API. We're using Google Play now instead of the regular Google Map API. So that we'll look at that. Probably not till tomorrow, or probably not till the 13th. Depends on how far we get. Looking at the use of external resources as well, and then accessing the phone resources is what we're looking at. Video, sound, manipulation, databases, 2D, 3D drawing, HTML viewing. This is really the roadmap for this weekend, by the way. So it's where all these pieces come together in terms of all the components in the libraries. So this information, by the way, and it's the same URL I mentioned last time, is available from developer.android.com, and this particular URL might have changed slightly, but the material is navigational if you go through their menuing system over at android.developer.com. So let me skip down here to the bottom. This is what we covered last time as a review. Traditional Java application, looking at the differences between Java and using Java on the Android system, where we have class A that uses class B, that uses class C, that uses class D. The entry point for the class, initializing the sequence of instructions that occur, and then the exit point, which is really a single entry and a single exit, actually, out of most classes that are running. And then in the traditional Java environment, we have a main program, and we run the main program that makes instances of objects in this particular example, and then it runs methods on the objects and stuff like that. So, and I'm kind of getting through this a little bit faster because this is a review of what we did last time. So simple Android application design, comparing it with that, which is what we really looked a lot at last time. In terms of there being an application screen, and then in each side of the application we have activity 1 and activity 2 and activity 3 and activity 4. And if we remember last time we did Hello World, and we had a name getter activity class that got a name, and then we sent the name to another main activity that we used inside of the program that we were running that displayed the information, did a Hello World kind of stuff on there. Using an intent to go back and forth. We'll look at some more intent examples today, actually. There's a couple of different things we haven't seen yet. We've talked about bundles and talking about transferring information back and forth between activities, which is also a good way of communicating. But to give you the big picture here in terms of our application design, what we looked at last time was using many activity screens or different activities with GUIs or views. So the view concept was also described with GUI elements that go inside of a view and the view hierarchy. We also looked at the different layouts for the views, the relative layout, the absolute linear layouts and things like that that we can put in terms of hierarchy of components that are going inside of the views. So the application here with the two screens, each screen is composed of one or more GUI elements, which is what this picture is showing you. So that's really what we covered last time. In terms of the design, here's a simple Android application design, and this one is using a map, actually, kind of approach to it, where we've got two activities. One is going to be responsible for, let's say, the main GUI. The other one's going to be responsible for, let's say, getting information in, and then dividing it out like with multiple activities, which is a great way of separating out the logic of the program. When we think about the object design and the logical design. So an application here which has two screens, a main map screen and a settings screen, and this would be the settings screens and this would be the main map screen. And each screen is composed of several different GUI elements. In this particular case, we've got buttons in here and labels and stuff like that. And then also looking at the initial goal. The goal is basically to have one activity with one view. And here we have a big text box on one of them, actually. And if we keep this logic consistently, then we have different views that go along with different activities. And then we have sort of the model view controller sort of concept that's being implemented. That's very, very nice way of putting the information together to create a logical form to the app. So today we'll be looking at logical structures of apps as well, and how to actually put one together using the correct components, and kind of the foundational material in terms of building bigger projects. We also have this application priority that goes on. So Android allows multiple applications to be executing at one time, and then simultaneously. So we have a service, which is an application. We looked at those different types of apps, different types of processes that were going on. And so we have active applications, visible applications, service applications, background applications, empty or canceled, garbage collected applications. So knowing the priority is kind of interesting. Anything in the background is a lower priority, obviously. Anything in the foreground is sort of like a Unix, Linux kind of concept. Foreground processes always have the highest priority. Whatever it is you have running right now, the main program is going to have the highest level of priority associated with it. So within the levels, you have the least recently seen is going to be equal to the first to be killed kind of environment, because we do have an automatic garbage collection environment in this platform. So anything that's out there that hasn't been used in a while, that's sitting in the background, it will probably end up getting killed eventually if we run out of memory resources on the system. We briefly looked at this last time. We'll look at a little bit more of it with our application lifecycle example in a few minutes. Which brings us to this slide, which is our lifecycle. So what we've got here are the activity states, and this is sort of at one point where we sort of ended at one part of last weekend, and I didn't go through this example. Instead, we skipped ahead to other stuff. So I kind of want to go back and look at this one, because the example itself lends itself really well to a better understanding of all the different application states. It's not like a traditional model of an application that's running on a computer where it starts up and it's there and then you shut it down, or you minimize the window, maximize the window. And it's actually kind of interesting because you can control each one of these states through methods. We've seen the on create, we've seen the on resume a little bit with some of our examples that we've seen so far, but we really haven't seen all of them put together, which is the purpose of this. So within the application, there can be many different activities or screens that are going on. And in terms of our activity state, if it's in the foreground, if it's running, it's active. So at one moment of time, we really only have one active. We could break it out and have multiple active, but normally we have something that's paused, or if it's inactive, or it's stopped when we switch back and forth between applications that are running. Each app runs in its own JVM. We can have multiple JVMs running simultaneously. I'm using the word JVM as a generic term. It's really a DVM. We went through the type of platform last time and the vocabulary for that. But I like to say the word JVM only because it's, I don't know, more familiar for more people. But what we're looking at here is the activities that can be killed, just like applications, based on priority as well. And states that are above are in priority order, which means an active state is the highest priority. Paused is underneath it, visible but obscured. So it's there. It's just you have something else loaded on top of it, in front of it. Stopped and no longer visible, but it's still in memory. And then inactive, not visible, not in memory, is terminated. When that can be collected easily. So within the application, there can be multiple different activities or screens. Activities are maintained in a stack. And so here's our stack where we have a new activity, the newest level, previous activities, and then the original activity, the oldest one's underneath it. So if you build up a stack, the way that the garbage mechanism actually works is that the lower ends of the stack end up going away. because the longer the system runs, assuming that your phone is going to be running 24 hours a day, 7 days a week, or your device is not really going to be turned off and on that very often, you're going to keep, definitely you're going to start garbage collecting something out of memory when you start filling up the memory. So it's going to go from a priority perspective. So the lower end ones are going to get consumed and removed a lot easier, a lot more efficiently. So in terms of the applications and the activities, they're just Java classes as we've seen before. We have the app application, app activity. So they're going to interact with them using member functions as we've seen last time. Let's continue our little review here. And initially we use the default application setup and focus on building activities, which is what we did last time as well. And then an application is selected on the device. It triggers the first activity to be instantiated. We set the manifest, if you remember, to trigger that particular activity that we wanted to see first. We built apps last time with multiple activities in it. And we switched back and forth between a couple of different activities as well. So what I want to do right now is sort of leave this up right here and talk about application states and go through that example that I didn't do last time that I kind of like actually, only because it's one of the rare times in which you actually see the activity states that occur. So this example that I've been talking about is up here in the, let me find it myself so I can show you where it's at. It is going to be, oh, and if you missed last time and you're curious about what we covered, or you missed, like you came back late from lunch or something like that, and you were here, these are the, from 3.9 and 3.10, there's about 13 different videos, and then that's approximately 13, 14 hours worth of recording, because each one of them is about an hour long or so. So it was a long weekend. So I won't be so brutal on you this weekend, because it's Easter weekend, but I know I've already had some people saying, hey, it's Easter. I'm like, well, you signed up for the course. You're here, and I didn't force you to come here. So I don't celebrate Easter, so it's not really a big deal for me. But all right, so if you go into the, let's see, it's going to be in, let's see. We are looking at the tutorials directory for this particular. And right here on the top, the lifecycle tutorial and the lifecycle solution are the two ones we're going to look at. And I'm just going to hit the logging right after that in the next few minutes here. And then that'll catch us up. And then we're going to go way down here to the tic-tac-toe one, which is going to be the, I'm just going to show you the solution I came up with. So for those of you who came in late, I took what we were playing with last time you were here, if you remember, about a month ago. We were doing a tic-tac-toe game with buttons and stuff. I just finished it, polished it up, finished it, and put it out there for you so you can see what it looks like. So it just didn't take too long to do it. So I am organized here. Here we go. Android tutorials. Okay. So the, oh, not the logging. Hold on one second. App lifecycle. So this is also an attempt to get us back on the track with using the tools again to refresh your memory. For those of you who haven't opened up anything for about a month, we're going to start looking at that as well. All right, so the app activity lifecycle. We're looking at the activity states, activity pause, stop, and kill scenes. Particular focuses on that. So the activities, that single focus thing that the user can do, can see. Usually each screen has its own activity, is what we're going to see here. And an application may have multiple screens, multiple applications, multiple things. And what is the paper for? Oh, okay, we have paper, if anyone needs paper. You know this is electronic nowadays, but it's okay. Are we having problems with the Wi-Fi? ITU seems to be working here. Meet-ITU. Is it working now? Is it working now? Okay, very good.
Meet-ITU, the signal is really low. Yeah.
I seem to have a good, you might want to turn it off and turn it back on if you're on a MacBook. Okay. No problem. Okay, so activity states. We have active, it's running. It's active, it's in the foreground of the screen. Paused. We're not on focus with this, but it's still visible. Retains all the state information. So in extreme memory situations, it might actually be killed. So just because it's running doesn't necessarily mean we have to kill it. If it's paused, it might be killed. We could kill it. We're going to see it killed probably in the emulator if we can get it running correctly. And stopped, it's not visible, retains all its state information, often will be killed if it's stopped. And what I mean by killed means that eventually, if we start running too many apps, the system's going to need to garbage collect it. When it garbage collects it, it kills it, or takes it out of memory. Because you haven't used it in like a day or so, you're not going to use it. So sometimes you'll notice it's just gone, not in memory anymore, because it got killed. So to see this in action, we're going to run the following example. We're going to create a new project and we're going to call it Lifecycle, so go ahead and do that. So I'm actually going to set my system up because I didn't do it, so I'm going to put my virtual box together. Basically, we covered this last time. This example can run on 2.37, so I'm going to go ahead and start up VirtualBox. Only because I don't want to use the built-in emulators. If you're still having problems setting up your development environment at the lunch hour, maybe I can troubleshoot some problems this time around. But hopefully at this point you have everything set. We're not going to go through all that stuff over again. But as a routine, I kind of like to have this set up because then when I hook up Eclipse, then I can just go ahead and connect the two of them. So I'm going to go ahead and load up Eclipse. And we're going to build this one from scratch. Later on, as we go through the day, I've got about, maybe 30 or 40 examples. We're not building them all. Because after a while, as soon as you've built like 3 or 4 of them, then it's like, oh, it's the same stuff over again. So we'll look at notes that are associated with finished projects, and we'll bring up the finished projects. So you want a working system in order to see these projects. But we won't build them from scratch each time because it'll be too slow that way. So, all right, but the first one we are going to build from scratch because we're reviewing it at this point still, trying to get our feet back in the water here, baby steps. All right, so I'm going to go ahead and connect my my ADB. It's a few more steps for me because I like to use the VirtualBox. But okay, so I'm all connected and I'm ready to go. So I'm going to create a new project. So remember we did this last time. We went File, New, and then we can go Project, or you can hit Other. It depends on your install whether or not you have an Android project option up there next to Project. Sometimes people do have it. It goes to the same screen. So we're going to create an Android application project. So make sure that that one is selected and click on Next. And I'm going to call this one Lifecycle. Lifecycle, as my instructions tell me to do. Oops, wrong set of instructions. Here's the set I need. And I'm going to give it edu itu as the path. You can give it any path you want. If you do cut and paste the code, just keep in mind that you'll have to make sure your path is correct. So I'm going to change this here to edu itu. There we go. And I'm going to leave everything alone. This is going to be built on a 2.2 Froyo, the earlier version. API 8 goes all the way up to 17, so it depends on what emulator you're running it on as to which look and feel you're going to get. I'm going to go ahead and press on Next, go through these screens here. New blank activity. I'm going to call it main activity. Doesn't really matter what I call it. And I'm going to go ahead and finish. Normally we have a main activity. It's kind of a legacy concept. Somebody's phone is ringing. It's kind of a legacy concept. Oh. It's okay. Like, I hear a phone. It's okay. It's all right. Let's see. So now my main activity, as I was saying before, we usually have a main activity if we don't have anything at all. And that's usually like the main concept of C or C++, and Java, the main starting point of the app. So let's see what we got going on here. So I'm going to go back here and say we're going to create the following code in the main activity.java file. So I'm going to try and cut and paste here because I don't want to I don't want to type. And then once I get this code into the project, actually I'll talk about it here before. What we're going to do here is that we are reviewing. We have our imports. Remember, we're importing packages. If we don't put the imports in, the Eclipse system will put them in there for us automatically as long as we select that option when we run into errors. This is what we get automatically. We get the public class main activity, which extends activity, because we're creating a class that is of an activity type. So it's extending activity. And we're going to set some variables in here. We're going to go integer pause is going to be equal to 0, killed is going to be equal to 0, and stopped is going to be equal to 0. And then we're going to create a reference for a text. So we have a text view, because we're going to put a label out there that says what state is our application in. And these are going to be counters to see how many times did we kill the application, how many times has it been paused, how many times has it been stopped. Well, stopped is probably not going to work for us. Because once we stop it, it stops, right? So logically, we can tell already kind of the system's a bit flawed, but you know, we're making an attempt to track this stuff. So we know about our onCreate method. This is what we looked at last time. We looked a lot about this last time, actually, where we sent and we received back the saved instance state. So the saved instance state that comes back is was it paused? Was it killed? Was it... Well, we're not going to get that back. Are we resuming it? What memory do we have? What information have we been using? It's basically our snapshot of the data that's going to come back through when we recreate. Well, when we recreate it, will we recreate it when we build it initially, or when we, well, actually when we build it initially, or we run a second instance of it that comes up, if we're able to do that. But we have these other states that we're looking at, so which is the purpose of this exercise, actually. So onCreate really only gets, maybe it only gets run once, I would say. But then we have an onResume, and onStart, onStop. We can create it, start it, stop it. So when we create it, we're starting it naturally. So the onStart is going to happen. And then we have the onStop, and the onStop is going to keep track of how many stops we have. So the code is actually fairly simple. It's listing out every one of the different life cycle stages. On the create, we're running super on create. And then we're saying, well, if the save state doesn't equal null, we actually have it, then paused is going to be equal to the saved instance state of get integer paused. So what does that mean? It says, well, if we had it, we should be able to keep track of how many times we stopped it, how many times we started it, paused it, by getting at the super information that's going to be sent to us when we get back the saved instance state. So when we put the application in behind by opening up another application and we pause it, we have the state data that's being kept. It's being kept in the memory that's going to be controlling the activities that are occurring, because this is of a type activity. We get these methods automatically because we're extending activity. So paused, we're going to get integer because we're converting this into an integer. We get integer pause that's been saved. Killed, stopped, these are those integer variables that we declared up here. So we're having our current pause equal to the saved instance state get int paused. And the killed is going to be equal to the one we have saved from the previous time we ran this program, or from the previous state that we were in. We're going to get the killed, and then we're also going to get the stopped that's going to come out of it as well. So the text is going to be equal to do the new text view this, create the text view, and then the text view dot set text, set the text on the text view. It's going to be paused plus pause, stopped plus stop, killed plus killed. So we can keep track of these three states that we're looking at. And we're going to set the context view to the text, which means put the text field on a text view, excuse me. I have to start talking Android now. So put the text view onto the context view. The context view is going to be our main window. So onResume is going to run super onResume. And this is the same format we're going to use for onStart. So we can look at this here, onStart, run super onStart, and just set the text. So run the view, excuse me, run the super associated state resume or start or whatever happens to be the activity state that we were in from the previous life cycle. Run it from super, get the information, put it to the text field. On the stop, we're going to stop ++ super on stop, run the super on stop, which is going to stop us. It's going to kill us. On pause, ++, super on pause. On destroy, killed ++. So we're incrementing the variables when each one of these things happens. So naturally what we should be able to do is run this app after we cut and paste the code and put it in there, stop it, pause it, and do all of these things if we can possibly simulate that. We didn't put a stop button in there, but if we hold out long enough, it would actually get stopped. So we'll play around with it a little bit. Let me go ahead and cut and paste and put this in here. Here we have our onsaved instance state that is running from up here, the onset instance, saved instance state dot get int. So on here we're going to go outstate put for the paused, the killed, and the stopped, which is how we're creating the information that we're getting from super when we run the activity state method that we're going to get, and we're going to look at the bundle that comes out of it. So we're saving the instance information. This is an overrided method, by the way. These are all overrided methods, by the way. Overrided from activity object. So, all right, so I'm going to cut and paste and put this into my main activity. I'm actually just going to pull the right from this point forward. I know. I'm sorry, there's nothing I can do about it. I know you don't have access. I would suggest, they were supposed to reset it. I would suggest turning it off, turning it back on, and then maybe contacting the guy that was out there if it still isn't working. Okay. It's working for some people and not working for others. You have to keep trying. You have to be persistent with it. So. At the first break, I'll do a follow-up on it, actually. So. Apparently there's one called Meet ITU that is also available, from what I hear. So I'm going to go into my main activity. How I'm going to get this project to work, by the way, is I'm going into the main activity. And I'm going to remove the stuff that's in here already, which is going to be the onCreate options menu. We saw that actually last time, and also the onCreate. I'm just going to pull everything out, actually, and just cut and paste and put this one in here. And what was that key combination to reformat it? Control Shift what? F? There we go. Control Shift F it. You guys use all the hotkeys, I don't. So, after hitting Control Shift F, my cut and paste looks a lot better now. So I'm going to go ahead and run it, and we'll see what we're looking at. Okay, so if I run it, I've already got my emulator running, so I'm going to run it as an Android application. And here it is. Looks like my other emulator from last time isn't working, but it's okay. I can have this one working. So I can see my life cycle has I just started it, so everything should be 0. So now if I hit maybe the, oops, hold on a second, let me get my mouse integration working correctly. If I come back here and go home and then run it again, what's it called, life cycle? Let's see if I can find it here. Somebody see it? Here it is, life cycle. Now it says pause twice, stopped once, killed 0. And so let's see, it stopped, because now I'm running it again. So I paused it twice. How did I pause it twice, though? That's interesting. So I incremented it when it loaded back up again. Because this one, after it starts, on create, it starts and then it pauses, because I haven't been using it. So I'm automatically getting a counter on that pause. I'm getting a counter on the pause that's in the background. So now this should increase then if I come back and go back to home and then go back and run it again. And then I could switch back and forth between the objects. Let's see. Where's my life cycle? Probably should have cleaned this guy out. Here he is right here. Pause 3 times, stopped twice, killed 0. So I haven't killed it yet. So I could kill it. Well, actually, by minimizing it, I've killed it. Because I have my escape key, which I just pressed, killed it. But my kill, as I mentioned before, isn't going to increment. Because it's not keeping track of it, it's no longer running. So the logic is a bit flawed. But on my emulator, I'm able to do this because I have the escape key hit to kill. So by using this, and if you have the same one here that we gave out, I gave it out last time. This is the menu button that would be on the side of the. It's a little app thing that just runs as a menu. It simulates the menu items that are on the side of it. If I can go through the menu, I can actually keep it running. If I have a menu working on the menu button actually works to hold up a menu. I don't have an options menu or menu for this app. But if I hit the home button, I can run it again, which is about all I can pretty much test is the starting, the stopping, excuse me, but not the killing. Because if it's killed, it's killed. It's just nothing's going to be saved. However, you could set some garbage collection or something on the killed event. I'm not going to be able to increment a counter, obviously, but I could do something. The state was reached, it was achieved, which means I could deallocate some memory. I could start up another process. I could make an app that doesn't kill by taking the kill event on the stop or on the kill and reload itself. So when it's killed, it just loads up itself again, over and over again, and then it won't ever stop. But if I'm going to do that, I'm not going to make an activity, I'm going to make a service, and I'm going to run it in the background. So I believe I still have this sucker running. So if I, where's my life cycle? Here it is. So now I'm back again. But now see, my paused was 1, my stopped was 1 instead of 2 on the paused. So it's a little bit faulty working with the emulator. You're going to get an approximation. Before, remember, I loaded it up. I did the same thing, loaded it up, and I had 2 pauses instead of 1. So now this should increment to, appears to be incrementing correctly this time. So the state should actually go to 3 now, because this will be the third, or excuse me, 2. 2 stopped, 2 paused. Eventually, if I leave this running, and I'm not going to do that, actually, I'm just going to leave it running, load it up again, I might actually get it killed. Because eventually it's going to be garbage collected. And if it gets garbage collected, then it's going to be killed. So what I'm going to do is kind of just leave this up. Leave it running. And then I'm going to come back before I run my next one. I'm going to try it again and see if I get the kill incremented on it. So leave yours running if you want. We're going to hit the next tutorial, which is going to be on logging, which is the other one I didn't cover last time. And then we'll revisit that to see if anything does get killed or garbage collected. It's possible that nothing's going to get killed because I only have 2 programs running. I could run something else or run it 2 or 3 more times, actually, and probably create it. If I had it doing something a little bit more memory intensive here, it's been a few minutes since it's been running, but let me just run up a couple more instances because I do want it to kill eventually. Here's my life cycle up here. Now, so I got 3. I'm just going to put up a couple more, see if eventually I can get something garbage collected. And then I'll leave it. We got 4. Nothing killed yet. Okay, so we got 4 of them running. At least I'm making an effort here. But that is everything I ever needed to know about the life cycle. I'm going to throw this away for a second. The other tutorial that we didn't look at that we should have looked at was this concept of the logging, because we're putting these little log messages in everything. And when we do that, what we're trying to do is troubleshoot and test our code so that we can figure out, you know, where is it stopping? Are we ever getting there? So we could put log messages in if we wanted to on our kill and on our other things to actually look at it in the DDMS or in the capture information for us. And then we can see what's going on. So we're going to create a new project this time and we're going to call it logging. And we're going to paste the following code into the main activity. Same thing as we did before. And I'll do that in a few minutes, but it's bigger on the screen here, so I'll go through it here. And again, we're not looking at too much on the, we're not going to look too much on the XML stuff. We did a lot about that last time. But here we're going to start the emulator, and then we're going to look at and we're going to view the logcat. This will work with your VBox emulators as well as your Android emulators. And that's basically all we're going to do. So I'm going to go ahead and open up a brand new Eclipse application. I'm going to close this one down because I don't need it anymore. I already have it installed on my emulator. If you run the VBox emulators, once you run the program once, it's there entirely. So you can, and I don't have logging in here, do I? Nope, I don't. So you can go back and run it again and again. Because some of the things, it's kind of interesting to see running after you already installed it. So I'm going to create a brand new, because we're going to work with this other, because I still have that other one out, waiting for it to be garbage collected. We'll see what happens. And it's still running, actually. So I'm going to be able to run another application on top of it. So I'm going to go into File, New, Other. And this one is going to be also an Android application project. So I'm going to click on Next. And this one's going to be called Logging. I'm going to call it Logging. And I'm going to change the package name to edu.itu.logging. Next, next, next. I'm just going to use the blank activity again because I'm going to fill it in. And I'm going to call it main activity. And I'm going to close this XML screen that comes up automatically. And you might notice, actually, because I'm looking at it now, I can kind of see I have some really interesting troubleshooting going on. You're going to get that. It's just going to show up in the console. And this is basically complaints about, looks like, well, I don't even know what these complaints are about, really. I really don't care as long as it works. So it's probably memory related associated with my VirtualBox emulator. So is what I'm thinking. Broken. I usually get broken pipes all the time, actually, and then it just retries. So it does a little bit of interesting, very interesting kind of red messages that come out. You can actually turn that off if you want to, but I leave it on just because occasionally I do see something that makes a little sense to me. So I'm going to go in and open up mainActivity.java, and I'm going to cut and paste again out of the example here. And let me tell you what the example is going to do here. The example here is really simple. So when the activities first call, the main activity on create is going to run for us automatically. On create, we're going to set the context view to the main activity, which is nothing really. And then we're going to run a log information for test me. And I'm going to show you how to track the logging. So what you end up doing is you put these log dot everything so you can log exceptions that are happening, logging information that's going to go on. You create these little cookies for yourself, and then you go into the DDMS. You set a tag, and then it's like a key pair combination. You look and you filter on the tags, and then you can see what's going on in your application. So I'm just going to go ahead and take these lines of code here and copy and stick them inside of my main activity, because everything else is pretty much given for me already in that template that I created. And let's see, I'll put it, I'll put it under here. I'm going to set the context view to main, and I am just going to, is it Control Shift F? Yeah, there we go. And then if I demonstrate again, just refresh your memory here, I didn't import the log. So that's why I'm getting this little red thing over here. Hover your mouse over, and then usually it's the first item on the list for the imports, which means I need to import. So don't be afraid if you see a bunch of red squiggly lines and stuff when you put stuff in. It just means you didn't go up here and you didn't put this in, I didn't put this in. So, and it was util.log I need to put in order to log something. So now if I run this application, I still have on my emulator, I still have my other one running. So we can see what happens with it. I'm going to load a new one on top of it, so we'll see what happens. So now I'm going to go ahead and start logging. And I'm going to run it on the same emulator because I was running the other one on. So I've opened up now a new application with all my broken pipes and stuff, and now I have this logging. It says hello world. So now what I'm going to do is open up the DDMS perspective in Eclipse, which is going to be next to my logcat, my other view that we were just looking at a few minutes ago. Select a window, open perspective, open DDMS. These are the old instructions. View the logcat button of the screen, and then create a filter for test, and then change the perspective back to Java when we're done. But let's go see what's going on over here. So we did this last time actually, but we never went through the example for it. So I'm clicking on the DDMS over here, and I should see from, and I have some other, looks like I have some tags that were created that haven't gone away yet. I should be able to create a tag, and the tag I'm going to do is going to be very similar to these, where I have, here's test me. Did I already create this tag? Let's take a look. I believe maybe I have already created this tag. Yeah, create a filter for test. Alright, so in our example here, let me switch back to the Java view so you can see what I'm looking at. In the code that I have over here, the tag is for test. So everything that's going to say test on it, I'm going to put from this application. I guess I probably could have called it logging application or something. And then the message I'm writing to myself is me. So if I go into the DDMS, I can already see I've created this filter. But what is this filter? I can take a look here, and I'll edit this one so you can see what I'm looking at. I gave it a filter name called test, and I am by log tag test. So I can actually create other ones as well if I wanted to by pressing on the button, the green plus button here, and I'm going to say another tag for test, and then was it capital test or lowercase test? I think it was lowercase test that I used in here as the key, and I can go OK. And so now when I click on another test, I see this test here, and I can see that the date on here was today's date and the time, and I see the process ID of the process that sent it, and this is the tag that was sent for my onCreate, from my onCreate method out here for this application. So now that I have this one running, I'm actually going to flip back and see if I've got anything killed yet. Waiting to see if anything is going to be killed. So I've paused that one, and now I'm going to come back up here to my life cycle again. Nothing got killed. Still, well, I'm not going to run out of memory yet, so I'm going to leave this running because I'm just kind of curious. So later on this afternoon, I'll test to see if anything got killed yet. Eventually, something will get killed if I run enough examples on it. I need to fill it up though. So I have 5 instances of this app running right now, with one of the other one actually going on. So I'm going to leave everything running so I can eventually hopefully get something killed and garbage collected. It might take a couple hours though, but we have 8 hours today, so we might see what's going on. So. Alright, so that was the logging example that we looked at, and we didn't look at. We were supposed to look at it last time, so that gets us up to date with this time around. So I'm going to see if I've left anything out in terms of this one. No. Okay, so I'm going to throw logging away because I don't need logging anymore either. I want to take a look at that tic-tac-toe one in a few minutes, but I want to finish my recap of the previous. Should have just left it open. I think I accidentally closed it for some reason. Here it is. It's still open. So that was a review of our activity states, and that was a one of the last 2 projects we needed to look at from last time. So here's that picture that we were looking at. It kind of gives you the big picture of what's going on with those activities. So in terms of the life cycle, so it's important to know the life cycle because then you can actually design your app to work with it, and then you can do certain things so that you know the functionality of the app becomes a lot more richer in the long run. So as the activity moves through its possible different states, we have the activity triggering different parts of the code that's going to happen. So remember, this happens for every single screen, for every single activity. So we have activities within activities. So the application runs with multiple activities inside of it. So when an activity stops inside of the application, pauses, switches, we can load up other activities, or we can detect things from other activities. As an example, you're going to use a GPS functionality for something. Depending upon the precision that you're looking for in terms of getting the longitude and latitude from the library that you're going to use, it's going to take a while. It might take a long time to get those coordinates. Do you want that sitting there while the user goes, waiting, waiting? Now you can stick it in an activity, pause it, wait for it to come back. It still could be running, and then resume it, come back to it. So on a resume, it might tell itself, resume once you found those coordinates. Come back up and say, hey, we're here, I found it. So you can actually have a better usability or better functionality. So sometimes programming the different states leads to better functionality overall in terms of the usability. So we have active, which is green, the visible here, which is red, and the blue is the active, paused, and stopped stages. So it's showing you it kind of dynamically, or in a graphic here, looking at the red, the blue, and the green to monitor the different states that we're looking at. In terms of our traditional Java application, we've seen that already. We've seen this already. I just want to make sure there's anything else in here we didn't cover from the first weekend. Nope. We've seen this already. We did, and I just want to review this a little bit as well. When we create multiple activities in each one of our applications that we're creating, because we can have multiple. There's rare you're only going to have one activity. Well, usually you'll have a couple of them. You set the manifest. As a refresher, we did this last time. We set the manifest with the name here, and we used an intent filter, and this is what this example is actually showing us right now, indicating that the activity is the first target activity that shows up. So this is how the application knows the initial activity that's going to be run. So you store in the application manifest, and then it's managed by Eclipse for us automatically when it runs through the Eclipse project. And we know we figured out how to take it out of Eclipse, taking that APK file, copying it onto an SD card on a device, and running it from the device. So we know how to do that as well. I also forgot to mention there is a way of actually connecting your device and syncing your device through the ADB, so it runs on your device, kind of like the same way it does in Xcode for iOS development. There's a way of doing that. It's a little bit trickier though. It requires a lot more setup work than running it through VBox, excuse me. So applications and activities, the manifest is what's controlling it. So the manifest of the application has two activity components associated with it. In this particular case, if we're running two activities, and it knows about both, and it knows about the intent filter, so we can switch back between both. Important Java concepts we also covered last time was the package concept for directories importing into Java. Inherit for activity super inheritance in terms of running super on create, we just saw a few minutes ago. And then, these are the links we looked at last time as well. So that, believe it or not, is a review of what we looked at last time in terms of all of the different concepts. So we're going to push forward now with newer concepts that build on this foundation. It's not a bad idea to revisit the foundation. Let's see. I'm going to kind of thumb through here. This is another one we did not cover, but I just want to make sure. We did the logging. So we did the debugging. We did, okay, listeners. Okay, so now what I'm doing is I'm thumbing through, because I've got about 50 lectures and you don't want me to go through all of them. What I'm doing is I'm picking out subject matters that we have looked at, but we need to take it a little bit step further on in terms of listener patterns. We cheat sheeted it. Instead of looking at listeners, we created an on-click method in our XML file to make a button work with a method. That's what I call a cheat sheet, because we're not using a listener for that, which makes it kind of, you know, it's not quite as functional, believe it or not. So there's different ways of doing it. So we're going to look at listener patterns and listener as a concept, because that's kind of universal with a lot of the different development that we're going to be doing here. So we've covered activities, we've covered activity patterns. So these are onCreate, onPause functions that are examples of listener design patterns as a design pattern. So according to Wikipedia, a design pattern is a general reusable solution to a commonly occurring problem within a given context. So that's your definition of what a design pattern might be. So it's a template or description to solve a problem that can be used in many different situations. The listener. We have tons of listeners. We need the listeners. Why? Because you can't do an on-touch listener using an on-click method. And on-click, how many times are you going to click on an icon? On a phone, you're not going to even have a mouse. So that's what I'm saying is if you rely upon non-listeners and you don't use the pattern correctly, you have limited functionality with what's going on. We did it last time because it was simpler. People want, why don't we just do this all the time? You can't, because you can't catch everything. You can't listen for everything with an on-click. An on-click is just an on-click. And you're working with a Java on-click, and you're extending a Java click, which is different for a mobile device, actually. So, and you're lucky it kind of works, but it's sort of a makeshift, hokey way of making it work. So, we have a listener, we have a subject, and then we have a listener number 2, listener number 3 with a subject. What's the subject? It's going to be the component, the feature that we're looking for, also called observer patterns. So listeners listen, observers observe. It's very similar concept. Some textbooks call it observers. Some people call it listening. I like to call it listeners because it's really what we're doing when we're putting in listeners. So we're extending listeners and implementing listeners. So maintaining a list of observers interested in the state changes of particular subjects automatically notifies the observer of each one of the state changes itself, often called a common method that all such observers implement. And we've seen last time we can actually put in observers for one button, or for a group of buttons, for a view, for all these different components. We can group them together by looking at their ID and saying, well, which one? I observed something happen. Well, which one did they drag, or which one did they drop? Stuff like that. Let's see. So the pattern is very common for a graphical user interface. Components of the application might be interested in notifying on a particular software OK button or something of that nature. Physical keyboard, there's a keyboard actually on most devices. So when a physical keyboard is pressed, something of that nature, when a GPS location has been received from the device, that may also be good. Lots of other different examples. Any class can be a listener if it subscribes to the updates. It is listening for updates, implements all the necessary methods that the subject may call when we use when we implement a listener. So they're typically on the on XXX methods. So on this method, then interface with that. So methods are gathered by the Java interface. Let's see, without specific functions and implementation, without any implementation, we don't get any actions that are going on in terms of the interface. So we've seen interfaces. We've been implementing interfaces. We looked at the interface concept in the Java class. Didn't look at it in this class, but we know it's like a protocol or it's like a template. So the Java class specifies the functions to be implemented, but there's no implementation in there, and it must implement all the functions it decides to implement the interface. So if we're going to implement an interface, we actually have to write the code for the functionality. So we're going to see listeners in a few minutes. I want to cover a few more concepts before we see that, because then I can kind of flip back and forth and mix it up a little bit between giving you textbook information and then giving you examples. So it breaks it up a little bit. Graphical user components. So we're going to put the big picture together here, and we're going to see groups of objects and view groups, where last time we just saw individual components that were put on views, and we saw different layouts for the views. So we have the view. Views are single widgets or controls. We get the view from the context, and then we can manipulate the view. So the view is how the users are going to interact with your application. We also have view groups that we didn't work with last time. We worked with single views last time, I believe. And the view group is one or more views combined together in groupings. It becomes handy because then you can work with an entire group of components and put listeners on components through the view groups instead of the views. Two uses of them are one for layouts, invisible controls that flow the other, other widgets themselves, and then advanced widgets, visible, implementing complex controls. So we can make a member of a view group and control the group together. So think of this kind of like when people make single versus complex data types. You can create a structure or a class. Let's call it a class because we're talking about Java. A Java class represents a student, and the student has a first name, a last name, a date of birth, or something like that, which would be considered a complex multi-factor data type. That's a view group. A view is like an integer, a float, a double, a single non-complex data type. So we create view groups that represent things like list boxes, well, a list box inside of another list box or something, nested components, more complex designs of components, or specific components we've designed ourselves. There is a huge, rich library of GUI components, so there's not much of a need to make our own components, but we can make our own widgets through the view group concepts as well. It's just a terminology associated with being able to associate multiple view items together in a grouping and then call it under one name, and then we can use it together. So here's our simple view items. Refresh your memory: the check boxes, radio buttons, text views, text edits buttons, spinners. More view items: the view flipper, horizontal scrolling is a view item, and then we have the list view. So the list view is of the type view group. Don't know if we saw a list view last time, but I think we may have. I'm not quite sure. I know we have one today, but if we haven't seen it yet, what we're looking at is labels inside of list items, which is inside of a scrollable component, horizontal component. So we're putting pieces together. This one happens to be given to us already. Yeah?
So are these still activities also? Or?
These are not activities. These are GUI components that are navigated or controlled by the activities. So what I'm referring to right now are the GUI components for the XML interface. So, which is going to be our GUI, our UI, our view. But it's interesting because the activity is constantly working with the view. So, and I originally started out talking about listeners. Listeners listen on view components. So it's actually kind of a, and I'm glad you mentioned that question actually, because here's the big picture. It's a three-part component. We have the activity that's linked to the view, or the, well, if we're talking about this in a model view controller, the view is the view, the controller is the activity, the model are the listeners, the data, the connectivity, all of the information that we're creating, that we're using with the views through the controller. But in Android, they don't call it a controller, they call it an activity, because we have, and I went through this last time actually, there's about 4 or 5 different types of controllers. We have, the activity is just one of them. We have services, we have, I can't remember, I'm not going to go through all that stuff right now, but we have different types of controllers that control views. We generally do assign one controller per each view. The view components are these view components here that come in single view or view groups, multiple views. And we put listeners on the groups and on the views, and the listeners are attached by using an on button, on list change, on tabbed index something or other, on XXX something. We put a listener, and so that when that item gets whatever done to it that it was supposed to get done to it on the on event, it sends back to the observer or the listener, hey, somebody clicked me. And then we have code or a method that's run by the activity that says, hey, they clicked the button, so put this little toast message out onto the screen or do something as a response to that. Which abstractly is how the 3 components work together. So it's kind of key. So it's good that we're kind of going through this right now, because it's kind of key to getting all the functionality implemented correctly. Because usually you're going to have a break in something. You're going to have a view item that isn't configured correctly or doesn't exist, or you're going to have a controller that's not controlling the view, or you have a missing activity or a method that's missing from a listener, or you didn't put the listener on the right item, or you put a listener on there but listener's not listening to to something. You have it listening to something else, a double click instead of a click or something, or I don't know, you have it listening to something. So, all right, so finishing up with the view groups versus the views. Here's a view flipper view, a list view, more view items as an example, progress bar, icon. These are view items. So everything is a view in terms of the GUI components. Seek bars, map views, image views as view components. So I'm going to throw these away as I go through them because then I know which ones I've actually hit. So let's see. So GUIs by example. Here's a stopwatch application as a component here. So when the record time button is clicked, the current time should be printed along with the results of the previous button clicks. So we have a scroll. In fact, in this particular example, what we're doing is we're just basically keeping a timer as a stopwatch, and then we have a button. So we press the button, it records the time. Press the button, records the time. So it's not really a stopwatch per se. It's just a record mechanism in this particular example. So what we're going to do is kind of see how the three pieces fit together in terms of the activity. So to program this particular thing abstractly, without looking at source code right now, but just looking at pictures, what we're looking at is a simple button and a click on a button. So we're going to have a listener that's going to listen to the button to click. And when the button gets clicked, we're going to do something, and what's it going to do? It's going to put a time in a list box. Or this looks like a list box to me, but it may not be. So we have a stopwatch activity. In the oh, it's a text view. Okay, so it's not going to be it's just going to be a text view, it's a small view. The stopwatch activity is connected with a button and a text view, and then it's composed of this X and Y composition is X is composed of Y. So we have X with the Y kind of, it's a basic UML kind of notation. If you're familiar with UML, you don't really need to be for this particular class. In terms of the context view, we have the text view that rides on top of the button. If we take a look at this picture here, we've got this is the text view that's up here. It's a pretty big text view, by the way. And we have the button that's on the bottom. So the context view that is displayed for the activity or the screen needs to be set to be an approximately layout position of the text box and the button, which is going to be underneath the button. We put the listener in the activity. The listener listens for the button. The button's going to communicate with the text view. So we don't actually have to tell the stopwatch activity anything about the text view. But the text view can be written or can be updated through the button activity, or the button method that's going to be performed when the button is actually using. So the button can be clicked by the user. Since the text view is unaware of the button, text view is not going to know about the button actually. The stopwatch activity will be set, the activity itself will be set to listen to the button. And the button's going to announce it's been clicked, and the stopwatch activity will then update the text view by the activity control that's caught by the listener. So the listener is on the activity, it's listening for the button, and then the button's going to update the text field. In this particular case, this is how the button's going to get the current time to end up on the text field. So in terms of the layouts, and this is what we looked at last time, putting all the pieces together, this time the layouts are view groups. So the layout is a component of a view group. So everything that's on the layout can be controlled by the view group component. So which are told they hold the views. Layouts are invisible. You don't see the layout, but it's there. Allows positioning of different elements, and layouts can be nested inside of each other. So we can put a layout inside of a layout inside of a layout. And the common layouts that we're looking at, I believe the old layout for the default used to be the linear layout. This one here, we're going to pick a linear layout for this application because we're just going to put it in a line. We're going to put the text view on top of the button. And in this particular case, the average default is generally the relative layout these days, but we can switch it. Just because the project was created with a relative layout doesn't necessarily mean it continues to use it. We can actually implement any layout we want. We import to the android.widget.name in terms of the input, and the name is going to be any widget component that we're looking at. So here's a vertical example, and then this is review as well because we've seen this. We saw it, but it did not go over the PowerPoint part for it. But we saw the different, in fact, if you go through the one that was called layouts, you'll see each one of them implemented. Vertical makes one column of the rows for the linear. Horizontal, linear, makes one row of views. So it's a row because it's linear makes it into a row either vertical or horizontally, actually. It doesn't have to be vertical. We have the additional layout parameters that can set for this. So when the view, such as a button, is added to the layout, the parameters we can set for how the view is going to be considered within the layout. And we saw these programmatically through a couple of examples, and here's the text part of it. The fill parent versus the wrap content. In a couple of the tutorials we've gone through already, we've changed things to fill parent. So fill parent expands the view as much as possible to fill the space of the parent container of the layout. Makes the screen, fills the screen essentially. Versus the wrap makes the view, be much larger, large enough to hold the components or containers, and can apply both to views and to height of the view. So when you're going to put components inside of a layout that's going to be inside of another layout or another view, and you're nesting things, it's common to wrap things because then you put it in relative to the particular underlying level of the hierarchy that you're working with. And so it'll be wrapped not within the entire screen, but within inside the area that you've defined for the view. The layout height and width, obviously just as it sounds, indicating the relative sizes of the multiple views when sharing a layout. So. Here's our simple example. If we were to take a look at this one here, and we were going to implement both of these two screens here on the bottom, the code that would actually be familiar with here is this one is going to be set to layout.horizontal. So we're using up here an example. In fact, you can cut and paste this code and stick it in. This is being done programmatically without using an XML file, by the way, which is another interesting kind of way of doing this. So a lot of people, including myself, don't like the XML editor tools that are inside. In fact, I will just switch, and instead of using the GUI, I'll just cut and paste and put XML code in there because I don't necessarily like working with it. Here what we've got is a non-create method for an activity. Because the activity is working with the layouts and working with the view, we can put the view components inside of the activity programmatically, create it all in one shot. Kind of like what we did at that first example when we created a text view and we put in the pause, the stopped, that indicator. So there's a lot of people that will do it this way because you'll have more control over it, especially if it's not that sophisticated, if it's a very small kind of view. And here's one way of doing it. And if you look at it, what we've got here is a button 1, button 2, button 1, button 2. And it's horizontal instead of vertical. This one's vertical. You can see over here it says vertical. It's really the same example. But up here we have, let's see. She's just adding the view. So nothing really too fancy here. Just button 1, which is going to be a new button this. Button 2, new button this. And then we're taking the button 1, setting the text to press me 2. And then here it is, the linear layout, we're going to call it linear layouts. The name is going to be equal to new linear layout this. Create the new linear layout, set the orientation to linear layout horizontal. And then add the view. This is very swing-like actually, if you're familiar with the swing, because create the layout, create the buttons, add the buttons to the view. So layout.addView button 1, layout.addView button 2. Set the context view to linear layouts. So instead of that line that we've seen, it sets context view to main underscore activity I think it's just main underscore activity is generally the default that we get, the XML file. This is equivalent to that with the same functionality and the same features essentially. And then over here we have the same thing, but the only difference here is it's vertical instead of horizontal in terms of that component. So here's our stopwatch actually. Just refresh your memory on what it is we're looking at. So we have the record time button, which is clicked, and then the current time should be printed along with the results of the previous button presses, so it keeps a tab on it. So here's what our layout would look like if we were to build this application. What we're looking at is the source code now that builds it. So what are we looking at? Stopwatch activity, extends activity. This part in yellow is the part you know about already. The part after it says implements, and now if we imported view, we wouldn't have to go view.onClickListener. But this is not done here to show you that if you don't import it, you can always preface, well, where's this onClickListener coming from? So we're adding the observer. We're adding the observer to the activity class by specifying an onClickListener in here, and this onClickListener is a interface. We're implementing it. So we have extends activity. From Java we know extends is inheritance. Implements means to interface. Implements an interface. We can implement many different interfaces. We only extend one class, if you remember that concept. And so we have button, button, text view, time, current time, linear layout, integer count. Very typical. Put all the variables up here. Define them out here. They're data members, if you're familiar with Java. So once we've defined our data members, let's look at our member functions, and we're going to do the entire activity is based on this lifecycle. So going back to the concept of that lifecycle, we have that onCreate method. OnCreate happens when the saved bundle, saved instance state is going to be sent to the activity. And then super onCreate, we'll create the super guy here along with the saved instance state that we've gotten. Now this is what we normally get. This line that's commented out is what we normally see in all of the projects that we've been creating so far and we've been using last time. We have the set context view to r.layout.main. This is not inside of R. This is not inside the resource folder. So instead we're going to do it programmatically, and when we do it that way we're not using R. So there's a lot of people that like to try to use R in there and go r.layout. Where it's not coming up. I'm not going to. So the resource folder is, remember last time, just another refresher of your memory, everything in there gets turned into Java. It's all XML code. All that stuff gets translated into Java, takes the Java code, puts it into r.class. R.class is housing all those components. We just go into there and we look for what we want, essentially. So now we're looking at the implementation that's kind of highlighted in yellow here for the XML file without using the XML file. So what do we got here? We have a button. It's going to be equal to a new button this. And when we're saying this, it's just basically going to be owned by this activity. It's us. Give me a new button instead of that super activity or to another or something else along the hierarchy. So this is the current object. New button and a new text field. And then the layout's going to be equal to a new layout this. Give me a new layout. And then set the orientation of vertical, because we want the text field, text box to be on top of the button. And then we have the linear layout set orientation. Then we have the parameters here. The parameters here are going to be for the width, the height, and the width or length. What do we have here? We have new linear layout parameters. We're actually specifying the size of this linear layout by filling the parent, comma, linear layout parameters, fill parent, comma, 0.9. In terms of the degree for the weight of it, for the sides, for the padding. Actually, it also sets padding when you think about it in terms of the window. And then the linear layout.add view, the text view, and then create the buttons. So the layout parameters for the button parameters, well, we have the text parameters and we have the button parameters. So instead of taking and making the button wider or smaller, or the text view wider or smaller with a mouse and dragging it and clicking it and making it, we're setting it programmatically by the height, the width, and the weight. There are 3 measurements that we're setting here with the linear layout. So once we set the button parameters, then we're going to add the button with the button parameters. just like we added the text field with the text view with the text view parameters. So we're programmatically setting the parameters of the box. How are you going to know that? Well, we arbitrarily set it. Probably could go out and take a common interface look, see what the measurements actually are, and then set it that way if we wanted to, which would be another way of doing it. So, and then button.set text to record time, which is the text that shows up on the button, and then button.set ID to 1. It's the same thing as going ID. So all of the things inside of the XML interface where we set the ID, set the on-click, set everything else, we can set in here, which is what we're doing. And then here's the other part here, button.set on-click listener to this. So we're setting the on-click listener. The on-click listener is going to be this on-click listener here that we've invoked up here, on-click listener. And when we do it this way, when we set the on-click listener to button, we're saying this activity has an on-click listener, has an observer who's watching the button. And then the current time is going to be equal to new time, create a new time. And then the count is going to be equal to 1. And set the context view to this linear layout that we've created, called linear layout. If you cut and paste and put this code into an Android project, it works. Actually, you could do it right now if you want to. I'm not going to bother doing it because we can see it right here. This is what it's going to look like. You click the button, takes the current time, puts it onto the adds it to the text view. Well, we haven't seen that activity yet though. So when we click the button, we have an on-click listener. The on-click listener is going to invoke something. So the stopwatch app, button click listener. So adding the activity as a listener to the button. This implements view on-click listener. And the on-click listener is what we have over here, button.set on-click listener to this. So down here, we've set the ID to 1, we set the on-click listener to this. This is the same code as in the previous slide, but the yellow marking is showing you the on-click listener part. If you leave this out, it doesn't really matter what you do to that button, nothing's going to get captured because there's no listener on the button. So. Now we're going to add and look at, in terms of the implementation of this, responding to the on-click message. So we're going to add here a class activity that's going to implement the on-click. So the one listener can listen to multiple different subjects, and then we can check the ID of the listener to generate the event. So this is the more efficient way of doing it. And what I showed you last time, we put, in fact you can still do it, you can put this event here, the on-click. So the on-click event from the view is what we put in the XML file last time. We said on-click equals my button activity, or my function of some sort that I'm going to run when the people click this thing. So what we're doing in that particular case is only listening to this event, and only on that button, which is limited, not quite as feature-rich. Just being able to do something like this. What does this do? We're going to create an on-click method that's going to be implemented by the interface. The on-click listener interface includes a method called on-click. And then on the on-click, we're going to check the ID. So the current time is going to be equal to set to now, current time, which is now's time. If the count is equal to 1, then to set text to something plus current time. Else, if the count equals to more than 1, which means the listener has clicked it before, append the text. So take text view.set text, set view get text, and then put in a line return on the end of it, and then add the current time underneath that. This is how we're getting the current time to append to the previous time. We're just keeping a counter. Yes? The on-click is generally implemented further down in the code, outside of the on-creates. The on-click method will be executed when the listener discovers that the button that it's listening to over here, set the on-click listener to this button, when this button is clicked, because we set the on-click listener, we can set an on-touch, on-drag, we can set different types. When the button is clicked, then it's going to invoke this particular method on-click. The method, by default, we don't have to say it's just for the on-click listener. From the interface, the activity that we're going to get that's defined in the interface says, well, on the click listener, invoke on-click. So we're actually required to implement this method, otherwise we get an error message that says, hey, you didn't override my method. You're including my implementation of this on-click listener, but you didn't implement the method because there's no code in this method. Originally, the code gets added by you when you implement the interface. Did I answer your question?
So how come the current time within the on-create method,
Mm-hmm.
we have the current time equal to method, right? So we are instantiating it here. But in the on-create method, we are using current time dot set now without creating an
Yeah, it's just updating it, updating the current time. We have it equal to a time, but that's when the object was created. If you think about the life cycle of the object, onCreate happened when the object was created. What if that app is still running on my emulator right now, and I click the button? I want it to be updated to the current time, not the time that was updated to when the app was created. It's a public variable, yeah. So current time is a public variable. It's going to set time to now is a method that's on the time class that's going to update the time to right now's time because we clicked it right now versus just the time variable that we created. When we created the time variable up here, current time, we're not going to do anything with it until we actually click the button. So we have it. We've initialized this current time to equal new time. So it's a new time, but we haven't set the new time. But we're going to set the new time when we click the button. When we run this on create, this really is just going to be initialized to a new time. New time automatically gets initialized to the current time unless we change it. But the current time is going to be when the on create ran. What about 10 minutes later when we press this button, then we're going to want the current time. So change the time to the current time, get the time now, add that one in there, and then put that one into the method. So this application is fairly simple in terms of its implementation by example. Did I answer your question, or are you still? Okay, good. You can cut and paste and put the pieces together, and it actually works, which is great. So specifying the layout in XML. So we did this programmatically. So we can do it in XML as well. It's very common to specify layout in text instead of the code format. So here's what we did last time. Actually, what we did was we used the resource layout main.xml, or it could be activity_main.xml. And then XML is extensible markup language, similar to HTML. We saw that before. So here's our specification here, where instead of doing this here, this is the code in the XML approaches, generates the same interface. In XML, the two buttons are nested inside the linear layout between the linear layout opening and closing tags. So we have press me here and press me here. This is the implementation of those two buttons. This is all of the linear layout opening and closing tags with the two buttons specified. Same thing we did here. So what we're looking at is the equivalence, apples and apples, which is more, I don't know, some people like this version, some people like this version. It's accomplishing the same task. It's doing the same thing. But notice in here, we're not setting an on-click here. We're going to still put the on-click listener up here. Okay. So that was a little bit more information upon what we had looked at last time. We looked at some view components last time as well. And what we're going to do eventually here is put all the stuff together into an example that we're going to write ourselves. But just to go over a few more concepts here, we know about the radio buttons. It's just a component. That's actually a group component. So we put buttons together. Well, buttons are buttons. That's a view component. A view group would be a nesting of similar components together. The layout is a view group. because inside of the layout we have all of the views that we're putting inside, and we're going to organize the views according to a particular pattern that we're going to specify for the layout. As an example, the radio buttons. So multiple radio buttons belong to a radio group. So we put a radio group in there, and we use it as a group so that we can organize what happens when you click on English, so Spanish doesn't, if Spanish was clicked, then the English is going to click instead, or something of that nature. So they work together, they know about each other, they're in a grouping. So the radio group manages only one selected component among the group. Exposes functions to programmatically select a button via an ID and also determine the ID of the button currently selected. So here's some code for radio buttons to take a look at this. So what we're looking at here is a very similar example as what we did before. We've got the button, text view, radio group, language buttons group. So it's called a radio group, and we'll create language button group is what we're going to call it as a public variable here, public data member. So language buttons group is going to be equal to radio group find view by ID r.id radio group. So this is what we did last time actually. Well, we didn't do it with buttons. Instead we saw it with something else. But out here in our XML interface that's on the right hand side over here, we have a radio group defined, and the radio group that's defined is horizontal, so it's going this way. This is a picture of the radio group actually. And in the horizontal grouping we have two buttons. We have a Spanish button and an English button. And we have the ID here, radio English, and then the ID here, radio Spanish. So we set the IDs for the, and this is under the Android :ID, which is, believe it or not, the same thing we did programmatically a few slides ago, setting the ID. And we can actually, as a other note, forgot to mention, we can actually use the strings that we created last time. We can use those programmatically as well. They don't have to be used through the R interface. So, in fact, this is not. This is using it through the R interface, but it's getting at the button that we have on the XML screen. That's in the resource folder. So again, if it's not in the resource folder, it's not going to be in R.java. So we don't have to use it that way. Or we don't use it that way. So text view is going to be equal to a new text view, find view by ID r.id text view. And so this text view here is going to be the text view that's going to be on the screen here, down here. It's not in our radio groups. This is our radio groups, by the way. And yes?
So what happens when I check the radio Spanish button works?
I haven't gotten to the code part of it. I'm just talking about the interface right now. That's coming up. So, on the click, when you press the button, actually, here's your answer to your question. We have the argument.getID. What button was pressed? Button.getID. So it's a method that we can run on the button that was pressed within the radio group that we're listening to, because we are sticking a listener here on the button.set onClick listener to this. This button is going to be button. No, that's this button here actually. Nope. The button is going to be, this is the radio group. So say hello. Okay, so yeah, the button is working with the radio group and the text field that's on here. We just don't have the text field in the radio group in the XML. So that when the button is clicked, it's going to get the ID of the button and say if the radio group.getChecked button item ID, this is to answer your question by the way, is equal to then the English one, then put in the English one. If not, then put in the Spanish one. We only have two, but if we wanted to, we could check the ID to see, is it equal to this one, is it equal to that one? So what we're doing here is on the button click, because we're really putting the listener on the button, it's going to say hello. We're going to click, depending upon which one of these, and we're going to get that by using the getChecked radio button ID. So it gets the checked button and figures out, well, which one is it? And you can put this in a case switch if you wanted to, or you can use in this case an if-else kind of construct to work with it. Not explicitly using the listener pattern for the radio buttons, by the way. not responding to the click, just checking what is clicked. So we can actually respond to these clicks as well. So this is just responding to a button click because we've put the listener on the button. This is the button here, and then we've got the listener for the button right here, actually, button.set on click listener this. Yes?
So when you click on the Spanish, on click will be triggered, right? So it won't.
Nope, we haven't put a listener on the radio groups. We've only put the listener on the button. It doesn't matter what we click on the English or the Spanish, that's not going to get picked up. The only thing that's going to be picked up is when we hit that button, because we put a listener on the button. And the button has an on-click listener on it. In this particular case, it's going to check to see, well, what is that one selected or is that one selected?
So when you click on the Spanish, only after pressing the button, it will.
Correct. We can also design it, as the note says on the bottom here, to be functional. We can put a listener on the radio group if we want, and then when something is selected, do something. This is basically showing you that the listener works with items that control other items. So we're not really controlling anything, although we could control it. We could set the selected differently. If, for example, this one that says, you know, when you fill out those forms on the internet, it says, you know, put your home address, and then it says work address and school address, and there's a little button that says same. You click the same button and the rest of it gets populated. What that's doing is just programmatically taking one address that you've put in and making the other ones identical to it. So you're setting those items. So if this one said set the language to English or something, then it could automatically, let's say, select the English button or something. So the radio buttons can also listen directly to clicks on the radio buttons. So what we're looking at here then is how we're going to get the buttons. So on the create method, we've got an English button and we have a Spanish button. So instead up here what we had was the grouping, language buttons group. So, and we had dot checked on the English button that we set. And so the grouping was actually put up here, was going to be equal to new radio group. So inside of the radio group, as I mentioned before, we have radio buttons. So just like the view group concept, we have components that are inside of the view groups that can also be accessed and used individually. So the button is going to be equal to a new button, find view by ID button. We have the button in here. We're going to take this one out here because we don't need the radio group anymore. So we're changing the code to listen for the radio button clicks instead of the button click. And so then we have the text view is going to be equal to the text view. And then here's the yellow highlighted code is showing us the differences where we have the English button, which is going to be equal to the radio button by the English button. The Spanish one is going to be the Spanish button by that ID. And then we're going to put two listeners on it. We have set an on-click listener. So on-click listeners work for buttons, anything you can click actually. They work for radio groups, radio buttons, checkboxes, all sorts of things. So the button.set listener, set on-click listener this, what are we looking at? Well, the text is going to be equal to hello, and then we're going to go English button.toggle. So on a button click here, we're going to toggle it so we can say that set the button set on click listener is going to set the listener. Then we're going to initially set the text to hello, and we're going to set the toggle to English, which means this one is selected by default. We're setting the toggle because we're not setting the group. The group here, up here we set the selected item, language button group dot checked, and we want to check this ID. Down here, instead of checking the ID, we're just going to take this one in, and the dot toggles the method. Says, hey, turn it on, put it on, which disables everybody else automatically. So the on click here on the event, where we're going to take and listen to see which of the radio buttons was clicked. And so what we've got is if the argument.getID is equal to button.getID, text2.set text to text, else if it's equal to the English button ID, or if it's say hello, and then set or set to hola. So we can check to see which ID was it, the English button ID the argument that was received. The argument that was received is kind of like command line arguments in Java, actually. When you take the array of text items that you put in past the name of the application that you're running, you can do the same thing essentially. It sends the argument automatically, so you're getting the ID. So if it's the button, then set the text to set text. So, which is the button actually on the onClick event. Otherwise, take a look at the onClick event, get the ID for the English button, Spanish button, French button, if we had more buttons. Here we only have 2, so we're doing the same thing before. It's either going to be English or it's going to be Spanish. Somebody else is going to be set to Spanish. So that's basically how, and you can cut and paste this code and stick it into a Android project, and it works just fine as well. And I have a GUI example for you that's going to have all this stuff put together, but it's going to be an example on steroids. So that we're not going to build, we're just going to look at it in a few minutes. But we'll have all these components together, but it's a little easier to look at the components separately to kind of see what it's going to look like. We also have the concept of the spinner. It would not be a mobile device without a spinner component. So it's a drop-down selection box with a list of radio button options inside of it. So again, it's another group. It's a view group. Provides a screen real estate saving over multiple individual radio buttons. So instead of putting them into a radio group, we're going to put them inside of a spinner. Spinner's a bunch of radio buttons inside of a grouping list box. Requires a different approach to the setup, an array of choices to present, and an array adapter to format the array of data for the spinner, and then an actual spinner view component itself associated with the array adapter. So here's what the spinner looks like in our spinner example. This one says it's going to have a bunch of cities on there, areas, countries, cities. So we set it up this way. And so we have a linear layout here with a text view on the top. Choose your city. And text view is going to essentially have an ID, city prompt, and then we have the city spinner, text view on the bottom. This guy down here. And then we have the spinner. It's going to have, well, this is the spinner here, and then we have the text view that's going to be on the bottom, the output text view. So it's working with a couple of text views in a spinner. When you select an item on the spinner, it's going to update the labels and the text views. So here's the code for it. So let's see what we've got here. We have a text view, a spinner, another text view. So we have one for the city prompt, the other one for the output prompt. And then we have this array adapter, which is going to be a character sequence for city adapter. And then we're going to have a string array here using the old-fashioned string with the city array. So this is going to be holding the cities. So let's see what we're going to do here. On the onCreate, this is the same code as we've been looking at so far, so I'm going to skip that part. Set the prompt at the top of the pop-up that appears. So that's going to be this part here. Set the prompt. So city prompt is going to be equal to find the city underscore prompt by the ID that's in the that we set in the XML file. So this is the city underscore prompt right here. It's the text box. And then I set the text of this text box to choose your favorite city. Why? We just probably could have just put it in here, but we don't have the text in here. We could have made a. So what we did last time was we made a string out of it. We took the string and we set the text using the string value inside of the XML file. Usually you're going to see it more along this lines here because then you're going to be able to change it. What if it's not cities? But what if it's something else? You can change it if you want to make it a little bit more universal. So the spinner is the city spinner, which is going to be equal to the spinner. Find the spinner. This is the spinner we're looking for, this guy right here, by city spinner, which is the ID that we're looking for. So here's our city spinner. Set the prompt to favorite city. So the prompt here is going to be what's going to be on the top of the spinner list. So it's like the title, but it's called a prompt. So the prompt appears at the top of the pop-up overlay. It's like the title. Why they call it a prompt, I'm not quite sure. Except for when you when this is closed down, when you press the arrow to make it smaller, you just see here, it says favorite city. And you click on the favorite city and it opens it up, expands it out. Okay, so then the output text view is going to be equal to the text view. Find the output text view, the one on the bottom. So then we're going to set up the array here. So we have the city array is going to be equal to a new string 5. Put 5 strings inside of cities array. And then 0, 1 through 4 are going to be our cities. So this is standard old Java programming. And then city last select is going to be equal to 0. Well, that's going to be the first one. We have 0, 1, 2, 3, 4. And then this is the different parts. So now we have a city adapter. So the adapter is a way of putting it all together for the view group, because we have radio buttons inside of a view group. So city adapter is going to be equal to new array adapter. And the array adapter is going to have character sequences in them as a data type. It's just the data type that's specified for the array adapter, which is going to be this android.r.layout.simple spinner item, comma city array. That's the city array up here. So we're taking the simple spinner item from our simple spinner item. We have our spinner here, city spinner. We're going to put it inside of a simple spinner item by taking the city array and exploding that and putting it inside of the simple spinner. So the city adapter is going to be a set drop-down view resource. This is the drop-down view resource. Because this is a view group, by the way, we're looking at multiple components that are associated with a grouping of items. So we're looking at the drop-down adapter. And so this is going to be called the simple spinner drop-down item. And then we're going to set the city spinner to set the adapter to the city adapter. The city adapter is what we just defined a few minutes ago here, with all of these different components that are associated with the characteristics of the title, the groupings, which one's selected, and then the drop-down nature. If we don't set the drop-down, then it doesn't come drop-down. It's going to be full screen, and then we're going to drop it down. So associate the adapter with the array, with the spinner, and the adapter here. So just make your computer easier to navigate. All right. Did you get a new computer? Oh, congratulations. No more of this stuff, huh? Okay, spinner. The listing for the selected items here is in the spinner. So let's look at the listener, which is going to be very similar to the buttons in the radio groups and the radio buttons. And so what do we have here? We have the on item selected. Because it's going to be different. It's not a click. It's going to be an on item selected. And then we're going to have a not on nothing selected. If nothing is selected, then we need to select something. If we have an item selected, we're going to look at that and pick the view from it and what position it's in. So in terms of our public methods, on the on item selected, we have the parent, the view, the position, and the ID as the parameters that we can set for these. And then we have the on the nothing, we're going to have the parent. Well, then what parent did it belong to? Well, it's on the nothing. This, by the way, comes from the Java docs that's associated with the SDK that's on the developer.android.com, by the way. So, unfortunately, I think this interface to the description reads like Greek for the most part to me. So, it's covered in some of these slides, but don't think you're going to learn everything there is about the concept by looking at the Java developer documentation. It's just not as feature-rich as you might expect, although it does give you a lot of details in terms of what methods and what parameters, properties can be set. So the listener for the events, so the selection event is in the spinner itself. So now we're going to implement the adapter view, because it's the adapter view that we're listening to that's holding each one of the items that we have stuck inside of the adapter. So it's the on item selected listener. So we have implements the adapter view.on item selected listener, and we have the cities populated here. We have the last city selected as 0, and then here's the new part. This is the new part of the code where we set the city spinner dot set on item selected listener to this. Just like the button where we set the on click listener to this, Very similar in concept. The only difference here is that we're using a different method call, so it's not on click, it's set on item selected listener. Some of these are depreciated from previous APIs, so if you get something that says, oh, it's not, it's set item selected or on item selected or something like that, then it means that they've changed the naming convention a little bit, but the activities is still the same. Functionality of the listening is still the same, I should say. So then we have the implementation of the on item selected. So this is different, and another thing important to note that I didn't mention last time is the first weekend when we put the on-click listener in the XML file, made it a property of the button, and then we made a method. The method wasn't called anything in particular, we just created a method to do it. We weren't using a listener. When we're doing this, we're implementing the listener method. Because we're using this method up here, we're using this listener. This is the on item selected listener. Instead of on click, we're going to have an on item selected convention. That's going to be for the name of the method that we're implementing. And we're overriding the method because the method already exists in the interface, but it's empty. So we're adding the implementation for that method here. So whether you see it with the adapter view dot, it's the same as the view dot. You might be able to, in fact, if you just import this, you don't necessarily need to include this up here. But it's nice in these examples that it's here because it's coming from a different package, because it's coming from it's a different type of listener. So it's coming from, and it's used in a different way. So if the position doesn't equal the city last selected, which was the one that we selected by default, that was the first one that we selected, then the output text.set text, and it cast it to a string, because that's a text box, we need to put a string in the text box. Parent.get item at position 0, 1, 2, 3, depending upon what position we stuck it into the array. Get that, set the text output, which is the text field, set the output to the text, set text, which is going to be essentially the text of the item that we selected. And then city last selected is going to be equal to the position. So the position we get automatically sent to us, and the position's coming through in terms of which item was selected, and we're also getting the ID, and we're also getting the view. So if we had multiple things inside of the adapter, we can get at each one of the different pieces that's inside of that. Because this happens to be an adapter with radio boxes inside of it. So this could have had something else in there with like 3 more components inside of it. So we can get the position and then get the ID of the item inside of the position and see what that one says. So instead of having one label, if we had like 4 labels or something, maybe these were addresses and it said name, email, phone number, and we wanted the phone number when they clicked on here because we want to call the person or something. Then we could get the ID of the phone number item from the view. Actually, it is a view. It would be a text view. So. And then we have another method that says on nothing selected, because we have the 2 items that could occur. We have a nothing selected or on nothing, or something selected or nothing selected, and we would implement that. In this particular case, we're not going to do anything, so we're going to leave it blank. So what ends up happening is that if you don't put this in here, the compiler is going to come back and say, hey, you got an unimplemented method going on here. Why don't we want to implement that method? So here's a little note to consider. Wait a minute. We have the setting up there right here. Isn't this dealing with the setting up of the interface in the code? Can I make an XML resource too? Yes, you can. We did this actually last time with colors. We created a string array with colors, and we took the colors and we added it. If I believe we did this, yes. We added the string array of colors to a box, to a list box. So we can do the same thing using a string, and we can use the same thing using the XML interface. This is just an example of doing it programmatically. Yeah?
How about like having a dependent value sets? How do we dynamically generate, filter out specific? For example, like when we have a value set, if I call it as a value set, it's one spinner for say country, and then we want the second spinner to list down the states in the specific entity selected.
Then you'd put a spinner inside of a spinner. And then you put an adapter inside of an adapter for the spinner inside of the spinner index. So inside of here, you'd have another one. So it said London on it, or maybe it said a state, and it had cities inside of the state or something. And then you can nest them as deep as you want, actually.
Two spinners.
Two spinners, one inside of the other.
So that the second spinner will be called from on click of the
Nope,
first.
it won't. The on click is going to be on the outer, but you can put an inner click listener on the in click on the item in here. So the question came up: what if you wanted to put a spinner inside of a spinner and your listeners? You're putting the listener on the view group. So if you have a view group inside of a view group, you could put you need to put a listener on the outer and also on the inner if you want to catch all those activities. Otherwise, whatever you click on inside isn't being listened to. It's the outer clicking that's being listened to. So you have to actually use multiple nested listeners inside of the multiple nested view groups, which
That will
is
actually hold
not
the current
hard at all.
selection.
Huh?
That's how you can hold the current selection and pass it on to the next
Yep.
spinner.
So what you do in that particular case is the same thing we did with the button and the radio buttons. If I selected this item here, item index position 0, inside of this position 0, I'd look at the components that were nested and say, well, which one of those is selected? Instead of putting a listener on there, perhaps. If you wanted it to respond to a click, same thing as the radio buttons examples and that other button. You can have the outer listener take a look at the information that's selected inside of the inner component, the view group, and say, well, which one of those radio buttons? Because here I could actually put multiple items in here as well. I could put checkboxes, radio buttons, labels, and all a bunch of stuff, and say, what did they put in here? And then you get at the ID, and then you get at the text. Set the text, or is it selected? Is it not selected? You get at the properties of the components that are nested inside. Really, if I were designing that, I'd just have one listener on the outside. Use the same listener in this particular example, but set up the inner components and just nest them. Nesting comes in handy because then you can, organize the screen a little bit easier.
I was actually thinking in this one. Can we go up
Yeah.
to the code even above? Yeah, like here we are implementing when we are the second one on item selected. So should we call the next spinner to initiate the
You could nest inside of that another call to the inside adapter that's going to have an item selected in it. You could nest the activity on there, yeah.
Because that's when I know what is the item selected.
Yep.
On that basis, I can actually create the different arrays.
Yep.
The
So
different list of values.
correct, because then let's say, for example, this thing had a where is it here? Let's say it had name, telephone number, email address, and text or something. I don't know, something else. Depending upon what the person clicked on, it could open up an SMS text messaging program, or a phone dialer, or an email address an email message. And if it were listening, so it could say, oh, you picked number 1. Okay, inside of number 1, if the position was equal to the, if it was equal to something else, if something was selected, what one was it selected, and then get the position of that selected item, and inside of that position, look at the items that are inside of that component, and then use the IDs of those items, and get the text, and use it for either this one was selected, this was not selected, or whatever logic you happen to be implementing, essentially. I've seen that done a lot, actually. It comes in handy. It's not too confusing either, especially if you nest it correctly and don't go like maybe more than 2 deep, 2-3 deeps in terms of the levels. You put a list, look for an item inside of an item inside of an item, then you're getting kind of hairy. A lot of what other people also do is they use the layouts this way. So you put a layout inside of a layout inside of a layout, and then you have a view group inside of a layout that's inside of a layout, and you have another view group that's, and then you can just like draw a map out in order to see it, because then it gets kind of hairy. It's kind of like nested ifs and elses. So, but it's possible and actually creates for some interesting functionality. If you think about it, that's how you're creating a view group. You're putting, some of the view groups are created for you automatically, but you could create your own grouping They're your own custom view group by just nesting, essentially. So those are radio boxes. Check boxes are very similar, but we have an on and off state. So we have two states that we're toggling back and forth. They're not organized in a group. They're individual. So some, all, or none can be checked in a logical grouping. Who's talking? Oh, she's talking. So I was just waiting for you to finish. I didn't want to talk over you. Okay. All right. Generates click events that occur. And so a click event only states that a click happened. So you need to be able to check the state of the checkbox to know which one. So you can call a Boolean isChecked method on the checkbox to see which one was checked. So here's the same example, but we've got 3 checkboxes. So the radio buttons all work together, the checkboxes all work separately. And why they made the buttons work together? Well, because usually you've got things that, just select one of them. And here, select all that apply. Kind of concept here. So WFU, Duke, and some colleges here. So here's our checkbox, where we've got the 3 different boxes. We're going to make local variables out of them by looking at the find view by ID from the R resource. This is what it's no, not here, but well, okay, we're going to skip the XML code, but this is how it's defined in the XML code. And then we're going to set an on-click listener to this, on-click listener to this, on-click listener to this. So just like the just like the buttons, we have a listener for each one of the boxes. If the box is selected, a listener is going to happen. So you can do the same thing with buttons, by the way. And then we check the ID to see which button was selected. Well, here's which checkbox was selected. So here on the on-click listener, and it's just one on-click listener, by the way. On the on-click listener, because I've seen this done differently with convoluted ways of creating multiple listeners with multiple actions that are occurred. And usually I see this when people put the on-click event inside the XML code and it calls a method. And it says on button click 1, on button click 2, on button click 3, and we actually did this last time. And now you can see why that's kind of sloppy compared to this. This is a little bit more organized. So again, if we're looking at if this one is checked, if this one is checked, if this one is checked, then do something else. And here we're just going to set a label, it looks like. We're going to set the text on the label to something on and off, on and off, on and off. So to update the status of something. So. Our edit text. On the edit text is interesting. Is the text changed? Has someone clicked in the edit text? What's the value of the edit text? So it allows entry of arbitrary text from physical or virtual keyboards. Typically, ends of entry is signified by an associated button being clicked or click event. Return being passed to the editable field. Key pressed events. Can constrain to only certain types of inputs, which is interesting. So you can take the event and constrain it, use it so that only numbers get typed in or only characters get typed in. So here we have an example of an edit text that's being used with, here's the edit text, here's a button that says write it. So it's going to write different things to the screen depending upon what you've got put in here. And here's the XML interface to it. It's a linear layout. Edit text is up here. And then we have the button. And then we have the text views. This text view that's down here underneath it. So let's take a look at the listener for this, which is kind of interesting. So it's going to implement a view on-click listener, comma, because we have here a button. That's where our view on-click listener is coming from. So when we click the button, we want something to happen. When we click the edit text, we also want something to happen. Well, it's 2 different listeners, just the same way as we saw an on-selection item listener for the other one. So we have a comma here. So remember, as I mentioned before, we extend one single class in inheritance. So edit text example activity or main activity, whatever you want to call it, extends activity. Only one. But we implement multiple interfaces. So we can implement on-click listener, comma, on key listener. So the key listener is going to be for the edit text, obviously. So what do we have here? We have 3 methods. three data members that we're going to put together here. One's going to represent the edit text, the button, and the text view. And then on the onCreate menu, we're going to set the context view to main. This is what we're going to do. We have our three. We're going to populate it by the r.id. As soon as about halfway through the day, I'm going to be skipping most of this. So as you can see, go through it once or twice, and then I'm going to pass through it a little bit faster, which is what I'm doing now, because we already know how to do this stuff. After you've seen it 20 times, you're going to know how to do it, hopefully. But this is the part that's in yellow that's of the significant value here. Write the button, which is this button up here that we've decided to create for write button. Excuse me, here it is, write button. So set the onClick listener, and then the edit text, set the onKey listener. So we have our two listeners being set. On the click on the key. So now we have two methods that are going to be overriding the default behaviors of the implementations of the interfaces, so that we can, on a click, v.getID is going to be equal to the r.id button, and then here all we're doing is basically setting the text to the get text. So text view.set text to the text view.get text from the text view with the edit text get text, and the edit text is going to be the text box that's underneath it, so we're just appending the text to it, which is going to be the click event. So on the click, take the text that's in the edit text box and append it to the text that's in the view on the bottom. And then on the on key, this is the interesting part here, we're going to look for the event. So the event.getAction is going to be equal to a key event.action down and a key code key event key code entered. We put a key in there, or was it that we just clicked in there? So did the text change, or did we put something in there? Did we take something out? Text view.set text, text view.get text, add it to the bottom. So both of them happen. So if we click in the text box that's above it and we change something, it changes down below, without just having to click the button. Or we could just click the button and we could take the whole thing down below. So it's kind of interesting because you can capture the events that are occurring inside of the edit text. Now here's some examples here of the edit text constraining types. So the type class, date, time, number, phone, text. So we can determine what's being typed in there by the type of data that's actually being put in. We get the type of data by the key code entered. So the action down says we have clicked into the field itself. Now we're putting a key code in there, and we can check the type that we're looking at. And the type's going to be a date, a time. Maybe we're going to put like a mask. Maybe we'll mask it, make it into a password field. There's also a separate password field that's set for us automatically. Is the flag autocorrect? Kind of flag is capitalized, lowercase, numbers, text. So you can actually go to this reference here for some more up-to-date information in terms of the different types of constraining types that are associated with the edit text. And here's a interesting one here, and this is what I was mentioning before. We actually have an edit text that does a password. It's actually called a password. The only difference is the same input type is going to be text password. So we have dots or asterisks. We can actually set the symbol if we want to whatever it's going to be. So password type here hides the letters after it's being typed, which is an event actually that's happening automatically on that particular item. So that's basically the only difference between a password type, a text password, and a regular edit text field. So, seek bars. Seek bars are kind of interesting. The seek bar here, the slider, allows the selection of the integer values being used in Natural Interface. So we have this actually in other interfaces as well. As you move the bar from left to right, and this is a horizontal bar, we can actually create a vertical bar if we wanted to as well. It increases from 0, 1, 2, 3, 4. It's just a graphic representation of a number scheme, or a number counting line. So we can set the minimum and the maximum, and then we can set the initial value. That's what we're doing here. So the constraints are: minimum is equal to 0, maximum It's settable to anything we want. Changes by 1, and starting the point of the knob can be set as a starting point. So senses initial of touch, ending of touch, and movements. So you would touch it with your, with your finger to move the slider bar or seek bar. What do you need that for? Well, if you're going through a bunch of pictures, it could flip pictures or messages or documents or something to go through a big old list of stuff. So here's what the code looks like for it. And what does this code look like? Well, we've got the old linear layout being used, and we have a seek bar component. And along with the seek bar, we have a text view that's underneath it. And then underneath the text view here, we're going to have, well, nothing else. That's it. So it's just text view. The text view here is just keeping track of what we're moving here. So every time we're going to move it here, we're going to put a listener on it. Every time we move it, it's going to update this again down at the bottom. Same code that we've been looking at all day, actually, so far. So now this is going to implement seekbar.onSeekBarChangeListener. So now we have an onSeekBarChangeListener, and this one's going to be implemented here with the seekbar that we've created, .set seekBarChangeListener. So this is probably maybe the 3rd or 4th time we've seen the same design pattern. So you're going to get a new pattern. You're going to get something you haven't seen before. It's going to be, I don't know, some new widget that someone creates. You're going to wonder, I wonder what the listener is called. Probably going to be called on something listener. Possibly change listener. So on, let's call my new widget my new widget. Then I'm going to take a wild guess and say it's going to be my new widget dot on my new widget change listener. Or click listener, or whatever this new widget is going to do. Same pattern, and then I'm going to do this down here. I'm going to go my new widget, good widget dot set my new widget change listener to this. So this is what I'm talking about in terms of a listener pattern. This is the design pattern that everything works the same way. It's just a different device you're listening to. There's a few variations. What do? You just look it up and you go, this is a click. Oh, this is a slide, this is a push, this is a seek bar change, this is an on-text change. And then how are you going to know this stuff? Well, you're going to go through the interface. Actually, if you let Eclipse do it for you, it'll build it'll build the empty method prototypes for you. You know, say, hey, would you like to implement the missing methods? Say, yes, I would. Or click on the implement missing methods selection of that error message that's going to come up. And what's going to end up happening is it's going to build these methods for you, depending upon what listener you've listened to. So we have an on progress changed, on start tracking touch. Do something on the tracking when you start moving it, and then on the stop tracking touch. So you've started tracking it, you stop the tracking, you've got the progress that's changing from point A to point B, depending upon what happens. All we're doing here in this particular example is just setting the text underneath here to say that that the touch started, the touch stopped. So here's our touch started, touch stopped, touch stopped, touch started. We're appending that to the text, meaning we have an on start tracking touch, on stop tracking touch. Most likely we're going to maybe flip through some pages or something, or show some pictures, or scroll through a list, or I don't know, change the index values or something. We're going to do something more functional. And then down here it's just going to tell us what we stopped on. What number did we stop on? It's an integer value, actually. Which is kind of interesting because other interfaces like iOS actually uses a float value instead of an integer value. So the precision is, but most people use the floats as integers, which is kind of interesting. So, I'm sorry? Yeah, it is more precise. You can make your own extension off of this though, and make it into a float if you wanted to. Actually, if you wanted more precision on it. But yeah, iOS uses a float. Android uses an integer.
Yeah. This reminds me of one application when I see it in flight search portals.
Yeah.
There actually it gives you, it allows you to select a range, like what price you want to look for.
Yeah.
So, but the difference was I was like you just have one button to move on, and in there actually there are two buttons which actually allows you to select the range. Like
Yeah, one selector for one property, the other one for the
in
other
the same
property.
sequence you can have two buttons.
Yeah, you can put two in there. Put 4 or 5, 6, 8 of them.
I missed that part. Where?
Oh, this is just the seek bar. This is actually right up here. Well, I didn't put the code. Actually, here it is. Right here, it's a seek bar. Just put 5 of them in there. Put different IDs on them, and in the code, have them
No.
do different things.
I'm not saying
Oh.
that. So like say like from flight from
Yeah.
destination what time? So you want to seek a flight between 6 to morning 6 to afternoon 12. So it gives a range from starting from 6 to like say midnight. But you'll have two bar. You can come here and then.
Oh,
it's
yeah.
two input, so two progress buttons.
You would have to extend this and make your own. It's not a default widget for the interface. Yeah, he's talking about having 2 of these suckers on here going from one end to the other end. I don't know. Actually, I've never used it. There might actually be built in. Every time the APIs get updated, they keep adding new widgets to it. So it might be one. And I'll have to take a look at it next time I go into Android. So let's see if this thing. Maybe I can make an assignment out of it. Is that what you said?
No, I didn't say that.
I'm still kind of curious. This has been running such a long time. I got 6 pauses, 5 stops. Let's see what happens here. I'm waiting for this thing to get killed. I don't know if it's ever going to get killed. Might be another day or so down the road. Where's my,
It's open up all the applications.
what's it called, life cycle? Here it is. Nothing killed yet. I'm going to leave it running. So I'm waiting for something. I wanted to get garbage collected, huh?
Open all the applications.
Open all the applications?
Let's see.
Oh, no, I'm not going to open all of them again. I think it's time for a break, actually. And then we're going to do some coding next. So let's take a quickie. This is 11:22. We'll look at some source code examples so you can see all of these widget components put together. So what do we want to take? Maybe a 10-minute break? So it's 11:23. We'll come back at 11:30ish. About 10 minutes? 8 minutes? 7 minutes? Somewhere around 11:30 to 11:35. How's that? All right.